A new view of the region closest to the supermassive black hole at the center of the galaxy Messier 87, M87, has shown important details of the magnetic fields close to the black hole and hints about how powerful jets of material can originate in that region. A worldwide team of astronomers using the Event Horizon Telescope, a collection of 8 telescopes, including the Atacama Large Millimeter, submillimeter array, ALMA, in Chile, measured a signature of magnetic fields, called polarization, around the black hole. Polarization is the orientation of the electric fields in light and radio waves, and it can indicate the presence and alignment of magnetic fields. We are now seeing the next crucial piece of evidence to understand how magnetic fields behave around black holes, and how activity in this very compact region of space can drive powerful jets, said Monika Mo, Cibrodzka, coordinator of the EHT Polarimetry Working Group and assistant professor at R. New images with the EHT and ALMA allowed scientists to map magnetic field lines near the edge of M87's black hole. That same black hole is the first ever to be imaged by the EHT in 2019. That image revealed a bright ring-like structure with a dark central region, the black hole shadow. The newest images are a key to explaining how M87, 50 million light-years from Earth, can launch energetic jets from its core. The black hole at M87 center is more than 6 billion times more massive than the Sun. Material drawn inward forms a rotating disk, called an accretion disk, closely orbiting the black hole. Most of the material in the disk falls into the black hole, but some surrounding particles escape and are ejected far out into space in jets moving at nearly the speed of light. The newly published polarized images are key to understanding how the magnetic field allows the black hole to eat matter and launch powerful jets, said Andrew Kale, a NASA Hubble Fellow at the Princeton Center for Theoretical Science and the Princeton Gravity Initiative in the U.S. The scientists compared the new images that showed the magnetic field structure just outside the black hole with computer simulations based on different theoretical models. They found that only models featuring strongly magnetized gas can explain what they are seeing at the event horizon. The observation suggests that the magnetic fields at the black hole's edge are strong enough to push back on the hot gas and help it resist gravity's pull. Only the gas that slips through the field can spiral inwards to the event horizon, explained Jason Dexter, assistant professor at the University of Colorado Boulder and coordinator of the EHT Theory Working Group. To make the new observations, the scientists linked 8 telescopes around the world, including ALMA, to create a virtual Earth-sized telescope, the EHT. The impressive resolution obtained with the EHT is equivalent to that needed to measure the length of a credit card on the surface of the Moon. This resolution allowed the team to directly observe the black hole shadow and the ring of light around it, with the new image clearly showing that the ring is magnetized. The results are published in 2 papers in the Astrophysical Journal Letters by the EHT collaboration. The research involved more than 300 researchers from multiple organizations and universities worldwide. A third paper also was published in the same volume of the Astrophysical Journal Letters, based on data from ALMA, led by Cyriaco Gotti, a scientist at Radboud University and Leiden Observatory, the Netherlands. The combined information from the EHT and ALMA allowed scientists to investigate the role of magnetic fields from the vicinity of the event horizon to far beyond the core of the galaxy, along its powerful jets extending thousands of light-years, Gotti said. The National Radio Astronomy Observatory is a facility of the National Science Foundation, operated under cooperative agreement by Associated Universities, Inc. The EHT collaboration involves more than 300 researchers from Africa, Asia, Europe, North and South America. The international collaboration is working to capture the most detailed black hole images ever obtained by creating a virtual Earth-sized telescope. Supported by considerable international investment, the EHT links existing telescopes using novel systems, creating a fundamentally new instrument with the highest angular resolving power that has yet been achieved. The individual telescopes involved are ALMA, APEX, the Institut de Radio Astronomie Millimétrique, IRAM, 30-meter telescope, the IRAM NOEMA Observatory, the James Clerk Maxwell Telescope, JCMT, the Large Millimeter Telescope, LMT, the Submillimeter Array, SMA, the Submillimeter Telescope, SMT. The EHT consortium consists of 13 stakeholder institutes: the Academia Sinica Institute of Astronomy and Astrophysics, the University of Arizona, the University of Chicago, the East Asian Observatory, Goethe Universität Frankfurt, Institut de Radio Astronomie Millimétrique, Large Millimeter Telescope. The Atacama Large Millimeter submillimeter Array, ALMA, an international astronomy facility, is a partnership of ESO, the U.S. National Science Foundation, NSF, and the National Institutes of Natural Sciences, NINS, of Japan in cooperation with the Republic of Chile. ALMA is funded by ESO on behalf of its member states, by NSF in cooperation with the National Research Council of Canada, NRC, and the Ministry of Science and Technology, MOST, and by NINS in cooperation with the Academia Sinica, AS, in Taiwan and the Korea Astronomy and Space Science Institute, K. ALMA construction and operations are led by ESO on behalf of its member states, by the National Radio Astronomy Observatory, NRAO, managed by Associated Universities, Inc. AUI, on behalf of North America, and by the National Astronomical Observatory of Japan, NAOJ, on behalf of East Asia. The Joint ALMA Observatory, JAO, provides the unified leadership and management of the construction, commissioning and operation of ALMA. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.